Quantitative analysis numerical concepts, algebra, inverse operations. Algebraic equations can also be solved by rearranging and simplifying terms. This process is sometimes referred to as opposite operations or inverse operations. The aim of opposite operations is to place the pronumeral by itself on one side of the equal sign, and on the other side of the equal sign solve the calculation. The general rule with operations, now operations equal the plus, the minus, the multiplication, the division symbols of an equation, is that when a number or a pronumeral moves from one side of the equal sign to the other side of the equal sign, the operation changes in function. For example, a positive on the left side of an equal sign will become a negative on the right hand side of the equal sign. Multiplications will convert to divisions, power 2 will convert to a square root, and so forth. Let's have a look at an example. Let's have a look at solving the equation using the opposite operations for the equation x plus 7 equals 11. So firstly what we'll do is we'll place the x on its own. And we'll say x equals. Now it equals 11, but we need to move the plus 7 to the other side of the equal sign. So when we move plus 7 to the right hand side of the equal sign, we remove the plus and we make it a negative 7. Therefore, 11 minus 7 equals 4. Let's check to see whether this solution is correct. So to test it, we'll use the substitution method. And the equation is x plus 7 equals 11. So let's substitute the x with our answer, which is 4. 4 plus 7, yes, it equals 11. Therefore, we know that our original solution of x equals 4 is correct. Let's go through a few examples. Subtracting an equation. Y minus 2 equals 3. So firstly, let's try to keep y on its own. So y equals 3. Because we have a negative 2 on the left hand side of the equal sign, we add on the right hand side of the equal sign. So y equals 3 plus 2 is 5. Again, we can test this equation by saying y is now 5 in our substitution method. 5 minus 2, yes, it equals 3. Therefore, we know that this solution was correct. Let's have a look at a multiplication situation. 2y equals 14. Again, we'll try and keep y on its own. So y equals 14. Because we're multiplying 2 on the left-hand side of our equal sign, we now divide the 14 by 2. So 14 divided by 2 equals 7. Let's test this equation. 2 multiplied by 7, yes, it equals 14. Let's have a look at a division example. P divided by 4 equals 8. So again, we'll try to keep P on its own. So P equals 8. Because we're dividing by 4, this time we multiply by 4. So P equals 8 multiplied by 4 is 32. Let's test our equation. 32 divided by 4, yes, it equals 8. So we know that our answer of P equals 32 is correct. Let's go through two additional examples. 9m minus 3 equals 60. So I'll start by saying 9m equals 60. Instead of minus 3, we now add 3. So 9m equals 63. Now we need to keep the m on its own. M equals 63. Because we're multiplying the 9 with m, this time we divide by 9. So therefore, m equals 7. Let's test our equation. 9 multiplied by 7 minus 3 equals 9 times 7 is 63, minus 3 equals 60. So yes, our solution of m equals 7 is correct. And for the final example, let's have a look at 3,600 divided by 20n equals 5. This time I'll keep the 20n on its own, so 20n equals. Now because the division symbol for 3,600 comes after the number, we then need to also divide 3,600 by 5. So 20n equals 720. Let's keep the n on its own. N equals 720. Because we're multiplying there, we need to divide 20. N equals 720 divided by 20 is 36. Let's test our equation. 3,600 divided by 20 multiplied by 36. 3,600 divided by 20 multiplied by 36 is 720. 3,600 divided by 720 equals 5. And we know that our solution of n equals 36 is correct.